Hey guys, today we're going to be doing AP Computer Science A free response question 4. The College Board releases these questions every year. I'll be sure to put a link to them in the description. So, the light board class models a two-dimensional display of lights where each light is either on or off as represented by a Boolean value. You will implement a constructor to initialize the display and a method to evaluate a light. So we can see here we have the class declaration. So we have a private Boolean 2D array called lights, and we have two methods that we're going to be implementing in the two parts. So part A, write the constructor for the light board class, which initializes lights so that each light is set to on with a 40% probability. The notation lights RC represents the array element at row R and column C. So, public light board int num rows int num calls. So we've got that. Now what we need to do is, the first thing we need to do is make sure that we initialize the lights array. So lights equals, new Boolean num rows num calls. Now, we need to go through and make sure each light has a 40% probability of being set to on. So we need to loop through every single light in this 2D array. So we're going to need a nested for loop. So for int I equals 0, I is less than num rows, I plus plus. So we start at 0 and we go up to, but not including num rows because this is 0 indexed. And same thing with the calls. Now, we need to make sure every element only has a 40% probability of being on. So we're going to create a Boolean value, like a temporary Boolean value. I'll call it temp, Boolean temp equals. And so to make sure we can get a probability thing, we need the math.random function. You might have learned about that previously. Math.random. Okay, and that gives us a random value from 0 to 0.9999999 whatever. So to get a 40% probability, we need to see, hey, this random value, is it less than 0.4 or greater than 0.4? And so we can just do less than 0.4 because we want it to be set to true 40% of the time. So we have that. And then we need to set lights ij to that Boolean value, temp. And that's all we need to do for the constructor. So part B. Write the method evaluate light, which computes and returns the status of a light at a given row and column based on these rules. If the light is on, return false if the number of lights in its column that are on is even, including the current light. If the light is off, return true if the number of lights in its column that are on is divisible by 3. Otherwise, return the light's current status. So this is kind of confusing, but we'll go back to this a couple times and make sure that we do this correctly. So, public Boolean evaluate light int row int call. So what we need to do is count the number of lights in that column that are on, because both of these conditions require knowing that. So to do that, we'll say int num lights to keep a counter equals 0, and we're going to loop through for int I equals 0. And what do we need to loop through? We need to loop through the length of this array, right? So we need to loop through each row because we're staying in one specific column, so we need to loop through each row. So, and we don't have a member variable for that, so we're going to have to use the inbuilt .length member. So we're going to do I is less than lights.length. That's going to give us the number of rows, and then I plus plus. Whoops. Okay. Now what we need to do is if lights, what row are we going to check? Well, the ith row. And what column are we going to check? The column that we're given, call. If that's true, we need to increment num lights. So num lights plus plus. Okay. Now, we have two different things we need to do depending on the case. If the light is on, we need to return false if the number of lights in its column on are even, including the current light. So, if lights row call. So what we're doing here is just checking, is the light at this specific location on? Just so we can do this first one. So if it's on, we need to check if the number of lights on are even, and then return false, which is weird. So how do we make sure we return false when it's even? Well, we can check if the number of lights on are odd. So we can do return num lights mod 2 equals 1. Right, so we need to, let's check if this works. We need to return false if the number of lights in its column that are on is even. So number of lights mod 2. That will return 0 when it's even. So, sorry, when num lights is even, this thing is going to be 0. So, does 0 equal 1? No, it equals 0, obviously. So it's going to be false. And we're going to return false in that case, which is exactly what we want to do. But what if the number of lights in that column are odd, right? We need to, then we don't, this doesn't account for that. What we need to do otherwise, return the light's current status. So if the number of the lights in that column are odd, we're going to return true, right? Because the light's current status must be true to be in this if statement. So that's already working for us, right? This checks if it's odd, and if it's odd, it returns true. So we don't have to make any changes here. But what if the light at that location is not on? Then we need to do this. If the light is off, return true if the number of lights in its column that are on is divisible by 3. Okay? So in this case, we need to return num lights mod 3 equals 0, right? So this is going to be, hey, is num lights divisible by 3? If it is, this is going to be 0, and then we check, hey, is 0 equal to 0? Yes, so that's true, and then we're going to return true, just like we need to. What if, though, it's not divisible by 3? Well, then we need to return the light's current status, which is off, because that's the only way to be in this else statement. So, if it's not divisible by 3, this is going to return false, which is exactly what we need. And that's all there is for these 4 questions. Thanks for watching.